Hi students, how are you? I think you all are doing very well. Last time our topic was redox chemical reactions, and today you are going to learn about how to balance chemical equations by the method of half reaction method. Okay, so let's get started. First step is you have to just write your general equation that would be given sometime, and over here you are given, let's say, hydrogen sulfide H2S plus we have here nitric acid HNO3, and that will give us H2SO4. There is another acid, and then this sulfur is used, then nitric oxide, and then what's left? Water. Here you have water. Okay, and this reaction we are going to balance this equation by half reaction method. Okay, let's get started. So in first step is you have to just find out which one is covalent compound and which one is ionic compound. So let me just highlight for you. This one is covalent and this one is ionic, and sulfuric acid is ionic, and these two are covalent. Alright, so when you come to know about your ionic compounds and covalent compounds, then the second step is you have to divide your ionic compounds into their ions. Okay, what do I mean by divide? Let me show you. The covalent compound is going to be same, there are no ions, but in ionic compound you can have two ions, hydrogen plus charged and nitrate ion, NO3 negative. Okay, so the next step is ionic compound again, H2SO4, hydrogen plus charged, and sulfate ion SO4 negative 2 charged. And as you can see here, we had here number of hydrogens by 2, so you have to add here 2 hydrogen. And I'm just going to give you a brief hint how you will get to know this is plus 1 or plus 2 and all about this. For example, when you combine hydrogen valency is 1, and sulfate ion, that's a polyatomic ion, its valency is negative 2. So when it comes to make a compound, their charges, their oxidation states, their numbers are used to be shifted, okay, without their signs. So 2 was there, that will come with hydrogen is 2. 1 was there, 1 will go there, but we don't write that one. So this is how H2SO4 is made. And for NO2 it's covalent, so we cannot depart it here, and water is also covalent. So in this step you will get to know about your ionic compounds and covalent compounds, and about ionic compound you have to depart them. Second step. In second step you have to assign them the oxidation states for all of your compounds. So here let's talk about H2S. As you know, hydrogen oxidation state is plus 1 because it's present in first group. But you have here 2 atoms, that means you have here plus 2. So to make it balance, the here charge would be negative 2 on sulfur, right? And hydrogen is already single ion here. Here we have NO3 negative. Over here, when it comes to find their oxidation state, oxygen is present in group number 16. So the charge of oxygen, the oxidation is -2. -2 times 3. Why 3? Because there are 3 atoms of oxygen. So -2 times 3 is -6, right? So in this case, you cannot do like, let me work over here. For example, 3 times 2 is -6. You cannot make here +6 to make that balance. No, because here you can see there is overall charge on this ion by -1. So you have to balance in such a way that you will get -1 back. So that's why you will make here nitrogen plus 5, and if oxygen is 3 times 2 actually -6 and plus 5. Plus 5 and -6, that will give you -1 back, then it's balanced. Okay, so this is how you will get to know about their oxidation states. For this one I'm just writing for one atom only. Okay, this is how you have to do. And here again we have same ion. Here SO4, again same thing. You can see the overall charge is -2. Okay, so you have to balance in such a way that it will give you -2 back, not 0. I'm talking about not like this compound. I told you it's +1 times 2 plus 2 minus 2 0. Why 0? Because overall charge is 0 here. Okay, but these are ions, polyatomic ions, then the overall charge is mentioned as it was mentioned with it -1. It's mentioned here, you have to get back -2. So oxygen oxidation state is -2 for one atom, because you have 4 atoms, that would be -8, right? So -8, and which number you want to add in -8 to get -2 back? So that would be +6. Okay, +6. How? Because +6 and -8 for oxygen. I'm talking about 4 atoms of oxygen. So -8 and +6, that will give you back -2, right? So this is oxidation state of sulfur here. And here you can see there is no charge, you just have to make balance. For one atom is -2, for 2 atoms that would be -4. So it means hydrogen has to be +4 to get you 0 back. And here also you have to get back 0, okay? And oxygen again -2, hydrogen was +1 for one atom, for 2 atoms that would be +2 and -2 0. So this is how you will assign their oxidation states. And then third step you have to mention, you can just check first here, where is the change in oxidation state. There can be change in oxidation for only 2 elements, okay, on each side. So let's just find out. You can see here the nitrogen oxidation state is +5 here and +4 is there. So you can just make an arrow. So you can see there is oxidation state changed from +5 to +4. And one more, sulfur -2, and here it is +6. Okay, now if this is +6 there, as you can see, hydrogen is +1 here, same, no change with hydrogen. Hydrogen is +1 here, hydrogen is +1 here. Okay, so it means there is no oxidation change for hydrogen. But let's talk about oxygen, the rest element and atom. This is -2 here, -2 here. I'm talking about only one atom, please keep in mind. -2 here, -2. See, there is no change in oxidation states, but only change can be seen in sulfur and nitrogen. So it means you have to write here your reduction reaction and oxidation. Alright, reduction means if the number is being oxidation state, if the oxidation state is being more after reaction, That means this element or this compound or that ion is oxidized. Okay, as you can see here, it's -2 and it's going to become +6. So this number is being more. Yes, -2, 2 plus 6. So this is oxidized. But you are not supposed to write only S. You have to write the whole compound where S exists. Okay, so this is oxidation. So I'll write here for oxidation. H2S, alright. I will mention just charge of the element specifically that has been changed. It is changed into SO4. It's one ion, polyatomic ion. You have to mention that, okay? SO4. It is +6. And reduction, as you can see, it was +5 before reaction. Nitrogen was +5, and after reaction, this is +4. So +5 is more than +4. Okay, so the number is being less there. So this is reduction, but you are not supposed to write only N. You are supposed to write the whole ion that consists nitrogen in it. Okay, all right, good. And here you can just mention the charge, the oxidation state of the specific atom that is being changed. Okay, and then there we have NO2 and +4 here. Okay, half of the method is done, just half steps are left, and I hope these steps you got it very well. If you have any question till here, you can ask me, and the next part will be shown in other video. Take care. Thank you very much.